Hey everyone, in this video I'm going to go over Linux special permissions. This is a follow-up to the previous video, so if you're interested in the standard permissions, I'll go ahead and include a card in the screen that you can click on to get to that video, and I'll also put a link in the description. So let's go ahead and check out our folder here. And here we have our octal representation. We have our all users permissions, we have our group permissions, and the owner of the file or folder permissions. Here we have the special permissions. So for the standard permissions, 4 is equivalent to read, 2 is equivalent to write, and 1 is equivalent to execute. For the special permissions, 4 is equivalent to the SUID bit or setuid bit, 2 is equivalent to the set group ID bit, and 1 is the sticky bit. So we'll start with the setuid bit. The purpose of setuid bit actually allows a user to run a file, like a binary or a script, as the user that it's set to. But there is the exception that in scripts, when the shebang, the octothorpe, and the exclamation point are used, that directive ignores the setuid bit. And so let's go ahead and create something we can run. Just make sure. All right, let's change it to our directory here. There's our file with our current permission. Let's go ahead and hop over to another console here. And we're going to check out this process. And we can see it's currently running under our account. Okay, so we hop back over to the other panel. Go ahead and finish that. And how we can change this is we specify user plus S, and then the file we want to run. Just remember, there is no impact on setting it on directories. And now we have some coloring here with our file from our terminal, and we also see the S here. So you won't see the execute bit here, you'll see an S. Now if the user that is specified doesn't have execute permissions, it'll actually be an uppercase S that you see here. So let's go ahead and run this as this user now. And hop over to the other console. And run our command again. Now we can see that the user the process is running under is root. And we'll hop back over here. Finish this. So there might be a couple of different reasons why you want to do that. Especially what I've seen is there are some applications that require actually setting that on certain scripts to allow it to run as root. You might even want to write a script that you allow unprivileged users to run. There are some security concerns with that, but it does avoid kind of creating a bunch of complicated sudo rules if you need to allow a lot of commands to be run for, a certain script for like an application user or something like that. So do keep in mind that there are some security concerns with that, and you can definitely do some research on that to discover what the issues might be that you could run into. So let's go ahead and clear that now. Now I'm going to go over setgid. When set on a directory, all subdirectories and files within that directory will be created with the group that's specified. So let's go ahead and see how this works. Give all users right. And our file is created with my user as the owner and my primary group. I'm going to go ahead and add the setgid bit. So you add group plus S. And remember that our original own group was root. And now, even though I created this with my user, the group remains root. And the subdirectory I created is also set for root as the group. And even files within subdirectories also have root set as the group. And just do a listing here. And we also get S in our representation of permissions, same as setuid. And setgid can also be used the same way that setuid is. So let's just check that out real quick here. I'm going to do group plus S on test. We'll have to run that. Let's see. And now, as you can see, it's running as root for the group. Okay. Jump back over here. Process. And let's go ahead and do some cleanup. And reset permissions on our folder here. Check and make sure. Okay, and now we're going to go over the sticky bit. And the sticky bit restricts file deletion to only the owner or root. So even if you are part of the group, or even if the like all users group has permission to write, they can't delete anything. So let's go ahead and demonstrate that real quick. Owner, I'm sorry, others and group plus write. And then we'll add the sticky permission, which is represented with T. And it comes at the end. And that is actually on the all users or other users group, where it will actually take the place of the execute bit in the list there. Okay, so now that we have our permission set, let's go ahead and create a file. Permission to all users to write. Switch over to another user here. Bob can't remove the file even though he has write permission. So let's go ahead and run command as root. Remove it, -T. And now Bob can remove the file now that the sticky bit has been removed. So that pretty much covers special permissions. And if you found this content helpful, I'd appreciate if you'd like and subscribe. Let me know what other content you'd like to see. Thanks for watching.